Hey guys, greeting from Centum Academy. So in this particular video, I am going to solve a JEE main level question on continuity and differentiability. The question is as you can see on your screen. So we have been given two functions, f of x and g of x, and we need to comment on the continuity of the sum of the two functions and the differentiability of the product of the two functions. Now let us first analyze this function. We see f of x is in the terms of modulus, and there is a GIF also, as I can see over here. So never start working with the mod and the GIF into place. So always simplify the function by redefining it. So first of all, I will redefine f of x. So f of x can be redefined as uh, x plus cos 9x when x is greater than equal to 0. Now, as we know that mod x will behave as x when x is greater than equal to 0, I've just replaced this mod x with x, and the greatest integer of pi square, that will be 9. So hence this becomes cos 9x. While when x is less than equal to 0, the function takes the form of x minus x plus cos 9x. So in other words, f of x is 2x plus cos 9x when x is greater than equal to 0, and just cos 9x when x is less than equal to 0. Now g of x, as you can see, is just a simple sine function. It does not change. Now when we talk about the continuity of the sum of these two functions, we can first of all comment about the continuity of each one of these functions, f of x and g of x. We know that f of x is continuous function. The reason being, it is made up of a polynomial function, a modulus function, and a cosine function. And each one of these functions are known to be continuous everywhere. Hence, the sum of all continuous functions will also result into a continuous function everywhere. So this will be continuous everywhere. While g of x is a sine function, and hence sine function is known to be continuous everywhere. Now by using the properties of continuous functions, we know that the sum of two continuous functions will always be continuous. So f of x plus g of x will also be continuous everywhere, right? So we didn't really need this definition of f of x in this part. This was easy to solve, and hence f of x plus g of x is continuous everywhere. So first option A is correct. Now if we talk about the differentiability, we know that f of x will not be differentiable at 0. The reason being, modulus x is not differentiable at 0. So x plus modulus x plus cos 9x will happen to be non-differentiable. So this function happens to be non-differentiable at x equal to 0. Okay. And g of x happens to be differentiable everywhere, because we do not find any kind of corner in this graph. Okay. Now when it comes to product of f of x into g of x, nothing can be directly commented upon its differentiability. As we have learned in the property of differentiable functions, when a product of a differentiable and a non-differentiable function is found out, we cannot really comment on its differentiability directly. So in this case, now we need to perform the multiplication process first. So by using our definition right here and right here, we'll find the product of f of x into g of x. So as you can see here, the product will be 2x plus cos 9x into sin x when x is greater than equal to 0, and it will be cos 9x into sin x when x is less than equal to 0, right? Now we have to find the right hand derivative and the left hand derivative of this function at 0. So if you are finding the right hand derivative of this function at x equal to 0, we need to differentiate this part of the function. So we can apply product rule of differentiation, and we'll find that the differentiation comes out to be 2x plus cos 9x into cos x plus 2 minus 9 sin 9x into sin x. At x equal to 0, this becomes 0 plus 1 into 1 into plus 0, which is actually 1. Okay. Similarly, for left-hand derivative, we need to differentiate this part of the function, that is cos 9x into sin x, which becomes minus 9 sin 9x into sin x plus cos 9x into cos x, right? And when you put 0, this becomes 0 plus 1 into 1, which is again 1, right? Hence, the product of these two functions seem to be differentiable at x equal to 0, and hence it is differentiable everywhere because the only point of contention was 0. So option number C is also correct. Hence B and D will be incorrect, right? So in this problem, the problem setter wanted us to use the properties of continuous and differentiable functions. Hope this solution was useful to you. Thank you so much for watching.